Okay, so you look around today and it's wild, right? We've got AI that can whip up these incredible images, write code that's seriously complex, even compose music. It really feels like we're on the edge of something huge. But then you look at the world of physical machines, robotics, and it feels like something's missing. Like there's this big, critical piece of the puzzle that just isn't there yet. So let's dig into that. Let's figure out what this missing piece is and what it could unlock for the next generation of smart machines.
All right, before we jump into the really cool solution, we've got to understand the problem, right? There's this fundamental bottleneck holding robotics back. It's a barrier that's stopping physical machines from learning as fast and as flexibly as the AI we see in the purely digital world.
So what is it? What's the one thing that could just flip the switch for physical machines? It's not about more processing power or bigger batteries, not at all. It's something way more fundamental, something you actually see in nature all the time.
And there it is. Motion. It sounds so simple, right? But we're not just talking about a robot moving from point A to point B. No, we're talking about the ability to learn, to adapt, and to get better at physical actions in the messy, real world, just like a living thing does. This one word, motion, it just perfectly nails the problem we're looking at.
Okay, but, just pointing out the problem is only half the story. The really exciting part is the solution, and it's this powerful idea called the self-refining data loop. And listen, this isn't just some small upgrade. It's a totally new way of thinking about how machines can learn.
So what is this thing? Well, picture an engine for intelligence that literally never shuts off. It's this continuous, self-improving cycle where every single action, every success, every little failure becomes the fuel for the next, smarter version of the model.
Okay, so how does this engine actually work? An idea is great, but let's break it down into real, concrete steps. This is how a machine can go from just, following a set of instructions to actively teaching itself to get better.
So here's the whole process, the 6 key stages. First, the machine's out in the real world, and it gathers data from its actions. Then, that raw data gets refined and labeled. Basically, it's organized and tagged so the AI actually knows what it's looking at. Next, this nice clean data is used to train up smarter AI models, and those new models, they get deployed right back onto the machine. Finally, the system learns from the results of what just happened, and this is the crucial part, the whole cycle kicks off all over again.
But here's the thing. The real power here isn't just in those individual steps. The breakthrough, the real magic, is the seamless, autonomous system that ties them all together. We're moving away from this old idea of an assembly line for AI models, and we're moving towards creating a living, breathing learning system.
Right, so this feedback mechanism is everything. You've got real-world data feeding the models, making them smarter. But then, and this is the genius part, those smarter models can actually figure out what kind of new data they need to get even better. So they start pushing the whole system to get sharper, cleaner, better data the next time around. And you've got companies like Codata out there right now building these exact systems.
And what this does is it creates this incredible upward spiral. The data gets smarter, so the models get smarter. The models get smarter, and they demand even better data. Let's really look at how this new way of doing things completely changes the game compared to the old way.
I mean, the difference here is just massive. The old way was a straight line. You'd collect data one time, train a model, and that was it. You're done. The quality was totally fixed. But this new way? It's a dynamic cycle. It's continuous data gathering and constant, never-ending improvement. It's really the difference between looking at a static photograph and watching a living, evolving organism.
Yeah, so this isn't just about making things a little bit better or a tiny bit more efficient. What we're talking about is a fundamental shift in how we build intelligent systems. It's not just progress, it's a total transformation.
And that brings us right back to where we started this whole conversation, motion. By creating systems that can actually learn and refine their own physical actions, we are right on the edge of finally giving robotics that missing piece. We're about to unlock a whole new future.
So if there's one thing to remember, it's this. A loop that keeps improving itself. An engine for learning that literally refines its own fuel. Think about that. We're not just building tools anymore. We're building tools that create better versions of themselves, over and over and over again.
And that leaves us with a really fascinating, kind of mind-blowing question to think about. From self-driving cars that learn from every single mile they drive, to warehouse robots that invent more efficient ways to move, what truly becomes possible when our tools learn to perfect themselves? The potential is just staggering.